Okay, so I'm going to go over our Unit 6, well, Unit 1 for us, but our most recent unit test, Systems of Linear Equations. As you work on your corrections, most of you for half credit back, you might use this to help guide you. So in the first problem, I've highlighted key information. There's a lot of it, and I've put in green here the fact that at each restaurant, a birthday person gets a free pizza. This is something that maybe one or two of you noted, but actually because it happens at each restaurant, we can work around that fairly easily. When I defined my variables, I said y is the total cost, and x would be the number of pizzas, not including the one that the free birthday person gets, so anything beyond that. Okay? In terms of the equations, G knows it's $8 per pizza, plus a $16 fee for the room rental and party favors. Venetian, $6 per pizza that we're buying, plus $24 for the room rental, party favors, etc. In terms of graphing, it was a little tricky to figure out the scale that you would use here. I chose to number by ones on the x-axis for the number of pizzas, and on the y-axis I numbered by fours, but you had many choices here. The key was where the intersection point was at $48. So you needed to have a scale that at least allowed you to see that point. So that might require a little bit of playing around with. Okay? You'll see I have the y-intercepts for Geno's at 16, and then a slope that's up 8 over 1. My pen's a little all over the place here. And then for Venetian, the y-intercept was at 24, and then it was up 6 over 1. All right, so what is the solution to the system of equations? Well, that's the intersection point. So that was at 4 pizzas. X was 4, Y was 48. In terms of explaining it, since they asked you to say what it means in the context of the problem, when you buy 4 pizzas at either place, the cost is the same, $48. Then at the bottom here, they had some questions for you looking to, assess your in-depth understanding. So, under what conditions would it be best to have a party at Geno's versus Venetian? Well, 4 pizzas, it makes no difference. But as you can see from the graph above, Geno's is a lower cost when it's less than 4 pizzas, and Venetian is a lower cost when it is greater than 4 pizzas. So going back to our graph, here, less than 4 pizzas to the left of this mark, Geno's is clearly the lower line, the lower costs. Once we get beyond 4 pizzas, Venetian is the lower line, the lower cost, the lower Y values. And then finally, if you and 2 friends are going to celebrate a birthday party, I accepted a variety of answers here depending on your rationale, but really from a cost basis, unless you're going to be eating 2 pizzas per person, Geno's is probably your better bet, especially where you're getting one of the pizzas you can eat for free. The likelihood you'd need 4 or more pizzas after that free one, I think, would be very low. Okay, so 14 points were available on this page. Then we go to page 2. So on page 2, we started off with a question about the Blast Off Music Company. They can make a total of 500 CDs and DVDs each day. It costs $8 to make each CD, $10 to make each DVD, and they can spend a total of $4,800 for production costs each day. So they asked you some questions about this. Here we've got CDs, we've got DVDs, we've got a situation where you've got what sounds like 2 rates of change, a rate of change for CDs, a rate of change for DVDs. This is an AX plus BY equals C situation. Standard form equation works well for this as compared to the slope-intercept form we saw on the first page. So if X I happen to define to be the number of CDs and Y the number of DVDs, you didn't have to do it in that order. You could have reversed these, but you'd still get the same results. My 2 equations were they can make a total of 500 total of 500 CDs and DVDs. So my number of CDs plus my number of DVDs has to equal 500. My second equation had to do with total cost. Each CD cost $8. Each DVD cost $10 to produce, and in total they can spend $4,800. So those are my two equations. X plus y equals 100, 8x, x plus y equals 500, 8x plus 10y equals 4,800. It's a little early this morning, so excuse me for any mistakes. All right, so in B, they asked you to solve that system. So you can see up here, I took my first equation and multiplied it by 8. So I got 8x plus 8y equals 4,000. And then in my second equation, I kept 8x plus 10y equals 4,800. And I chose to subtract this second equation from the first. You could have done this differently. You could have multiplied the first equation by -8. You had choices there. But when all is said and done, I found that y was equal to 400 DVDs and x is equal to 100 CDs. And they asked you to explain your solution in the context of the problem. So based on those numbers, Blastoff can make 400 DVDs and 100 CDs for $4,800 in the same day. That would be my explanation. Okay. Number 3, fast photo, pretty pictures. We had a situation here where you were asked about 2 businesses that print photos from digital cameras. In the first case, they asked you true or false. There is no number of prints for which the cost at both stores is exactly the same. Well, I went about and solved this. I set up 2 equations. Y equals 0.69 x, 69 cents per print, plus $10 setup fee. That's the fast photo equation. Okay. In the second case, I had y equals 99 cents per print with a $6 setup fee. That was pretty pictures equation. I chose to do elimination here. You could have just as easily used substitution. That's your choice. When all was said and done, what I found as the solution here, the point at which it doesn't matter which place you go to, was where x was 13.33 prints, okay, because I defined x to be the number of prints, for a total cost of $19.20. Well, 13.33, we cannot buy 13.33 prints. So I said, this is true. There is no number of prints for which the cost at both stores is exactly the same, because that's, we can't buy in partial prints. So that was my explanation. In B, they asked us if this equation can be used for pretty pictures, and some of you said yes when you actually meant no, when you had the right idea for the equation. This required some close inspection. The equation for pretty pictures is actually 0.99x plus 6. They had these numbers reversed, so that should have been false. The fixed cost here is 6. C, it's always more expensive to have your photos made at your prints made at Fast Photo. Well, that's false. You can do a little modeling here. We know it's the same cost if we were able to buy 13.33 prints. So I tried, what if x is 15? Well, if x is 15, I see that Pretty Pictures is actually more expensive and Fast Photo is less expensive. So you need to do a little playing around with some numbers to see what happens around your solution. When it's greater than 13.33, which one is more expensive? When it's less than 13.33, which one is more expensive? And then here, if Jorge paid $20.85, he must use Pretty Pictures. Well, that was convenient for me because I had actually tried 15 photos in my modeling here. So I happen to already know that Pretty Pictures produces a cost of $20.85 when 15 prints are purchased. All right, moving on to the third page. Here you were asked to look at a variety of equations, systems of equations, I should say, because a system involves 2 or more, and you needed to solve them. So I chose elimination in my first problem here, but you could have chosen substitution. That's up to you. Elimination is the one, though, where we're getting rid of a variable, solving for the other, and then putting that value back in to find the one we eliminated. If you chose substitution, you would have come up with an expression for either x or y and substituted that expression into the other equation to solve. The answer here should have been 6, 8. Those of you who did not get this, check your work and your signs. Signs seem to be an issue here. For B, I happen to choose substitution here. Lended itself very nicely to that, where we already had an expression for y. When I solve this, when I put in negative 2x plus 3 for y, I got 2x minus 2x, which of course goes away, plus 3 equals 3. When I subtracted to get nothing for 2x minus 2x, I was left with 3 equals 3. This is the classic situation where these two equations are actually the same equations. Sorry, the lights went out here, but I think we can still see. They are actually the same equation. I can rewrite this second one if I subtract 2x from both sides as y equals negative 2x plus 3, which is exactly the same as the first one. So this is the case where 3 equals 3 for any value of x. Therefore, they're the same equation and there are infinite solutions. The lines would lay right over one another. In C, let's get the right view. Okay, in C, I again chose substitution since I already had an expression for y. I put that in for y in the first equation. Okay. And as I worked on that, I found that when I did my distribution, I had 3x minus 3x minus 1 equals 1. 3x minus 3x goes away. I get negative 1 equals 1. Well, that, of course, is not the case. It's not equal to 1. Therefore, there are no solutions. This is the case where the lines are actually parallel. I could rewrite that first one here. If I subtracted negative 3x from both sides, I get negative 2y equals negative 3x plus 1. If I divide by negative 2, I get y equals negative 3x divided by 2 is actually 1.5x. 1 divided by negative 2 is negative 1/2. That first line has a slope of 1.5. The second line has a slope of 1.5. They are actually parallel lines. In D, here I used elimination. I chose to subtract the second equation from the first after multiplying the first by 2. Okay, so I restated the first one as 4x plus 12y equals negative 2, multiplying all of that equation by 2. And then I subtracted the second equation from the first to get rid of my x term. I ended up with 12y minus negative 3y, which is 15y. And negative 2 minus 3, which is negative 5, and I got y equals negative 1/3. And when I put that in to my first equation, 2x plus 6y equals negative 1, I put the negative 1/3 in for y. I ended up finding that x equals 1/2. So my solution here was 1/2 negative 1/3. Okay. On the bottom, you needed to explain what method did you use. Substitution was fine for E if that's what you did. Okay, so you needed to show that you knew the method you were using. I happened to use elimination because I could easily get rid of x. So whatever you chose here, you just needed to explain it. The system that had no solutions, that was C, the parallel lines case, and the system of equations with an infinite number of solutions was B, where they were actually the same line. Okay, and then the last page. You had two phone plans here. You had Campus Connecticut plan, University's phone plan. The fixed cost was $25 in the University phone plan. What was the better deal? I actually looked at the situation to find the solution was at 125 minutes. For me, that meant that I would choose University because I will definitely use greater than 125 minutes in a month. And it's important to note that M represents minutes, and each of these plans is for a single month. Okay. When do the two plans cost the same? I had already found that to be at 125 minutes. They both cost $37.50. You can see my work above. Okay. For the table, they told us the first 40 minutes were free, and after that you pay 35 cents a minute. So the first 40 minutes should have been zeros. After that, well, 50 minutes is 10 more minutes than 40 times 35 cents, $3.50. 60 minutes is 20 minutes more than 40, so 20 times 30.35, $7, and so on. They said, write an equation that models the cost. You had some choices. I chose the 0.35x, but then I had to subtract the fact that the first 40 minutes are free. So 0.35x would be for all the minutes. If the first 40 minutes are free, I subtracted that cost. So I got some version of this equation. Okay, and you can see some other thinking here. And then for F, you needed to come up with a reasonable explanation as to which one would be better. You can see my work here and my thinking. And I'm going to close out here because I think we're over time.